Hey folks, here's the third online lecture about Fourier series. It's relatively short. Here we go. Um, we're talking about what if I have a function and I have found the Fourier series and now I just shift the function over. What happens? What gives? All right. So let's start with a very simple example, and this is the example we're going to talk about for the whole time here. Here's the square wave. All right. Again, it's 1 on the interval from 0 to pi, -1 between -pi and 0, and then you repeat that every 2 pi. All right. So period 2 pi. Square wave. We found back on day one of doing Fourier series kind of stuff, we found that the A naught, the average value of the function, is just 0. We found actually all the coefficients of the cosine stuff were 0 because it was an odd function, so there's no cosine stuff there. And then we found out that the B sub n's were 4 over n pi as long as n is odd, otherwise it's 0. So there's only odd frequency stuff showing up here. Okay, and so we had B1 was 4 over pi, B3 was 4 over 3 pi, B5 was 4 over 5 pi, etc. You can add all that stuff together and say f of x square wave is equal to this infinite sum of 4 over pi sine x plus 4 over 3 pi sine of 3x plus 4 over 5 pi sine of 5x plus ... on to infinity. Of course, the more terms you get, the more accurate your approximation is. All right. So now what happens if I shift that square wave to the right by s for some number s? Okay, that's what that is right there, not a 5, it's an s. Then, well, we can say, well, then f of x minus s, remember you're shifting to the right, so you subtract the s part, is 4 over pi sine of x minus s plus 4 over 3 pi sine of, that should be, I'm sorry, that should be a 3 times x minus s. I got excited as I was writing, all right? And the trick is that we don't do that. And it's because when you get a signal in, you're not necessarily thinking, oh, that's just an old signal that I know it's just shifted, right? I mean, you're not going to necessarily recognize that this is just the square wave and I need to start it right here, but rather it's just a wave and it's doing something, right? And so if I don't recognize it's just an old function just shifted to the right, I'm just going to find the Fourier coefficients for it, right? You give me a function, I'm going to find Fourier coefficients. I'm not necessarily going to look at it and try to see if I recognize, oh, this is just that function, whatever, right? Nothing actually is that neat anyway. So you're going to go through the Fourier coefficients just as normal. But somehow these new coefficients should relate to the old coefficients, right? So for instance, a sub 0 shouldn't change. And then I'll leave it to the reader to the audience to say, if I shift things over, why doesn't a naught, why does it not change? Think about that. And then these coefficients a sub n and b sub n, they're measuring how much of a certain frequency that function sort of had, right? How much frequency n stuff is there inside that function. So if I were to shift things over, the function, at least the frequency hasn't really changed, it's just been shifted. So the question is, somehow those coefficients don't change, but yet in this instance they have to, because if I were to shift the square wave over to the side, it's no longer an odd function. I can't just get rid of all the cosine stuff and keep all the sine stuff, but something needs to be consistent here. And then I'm not going to answer that. That's the homework. All right, so here's your homework right away. Let f of x be a shifted square wave, and I've just shifted to the right by pi over 4. All right, so you can see right here, pi over 4 to pi plus pi over 4, it's 1, and -1 down here, right? So it has this thing here. And so if you were to chop it off between -pi and pi, you would get just this part right here, where it's over, drops down, goes back up, all right? So the question is now, we'll find a sub 0. Well, you can just look at it, hopefully, and figure out what that is. And then find just A1 and B1. And now, if you do this thing full out, finding A1 actually takes 3 integrals. You get a piece, a small piece where it's +1, another piece where it's -1, then another small piece or smallish piece where it's +1 again. So it's 3 integrals. It's all the same antiderivative. It's not hard. It's just evaluate it in the right places. Same thing for B1. So it's more accounting, basically, right? Keep track, bookkeeping, keep track of what things are. Be careful with minus signs and stuff like that, but you'll find some values. And now the question is, recall, or last question is, recall that with the regular square wave, A1 was 0 and B1 was 4 over pi. What relationship do you see now between the values that you found and these old values? And it's an open-ended question. When I say, what relationship did you find? I mean, there's lots of answers that are true that are not meaningful. Like you could say, the relationship is they are all numbers. Yeah, great, thank you, right? Give me a meaningful relationship that somehow relates to the question from before about how this frequency stuff hasn't changed, but my coefficients have. What gives, all right? So it's open-ended, but do the best you can, and I will see you in a future time. Take care, everybody.